Ohm's law, V equals IR. So the idea is that you have a resistor, you got the voltage, you got R, you increase the voltage, you increase the current, you decrease the voltage, you decrease the current, and it does so linearly. Double the voltage, double the current. Negative voltage, that would be current in the other direction, so it'd be negative current. So it's pretty much straightforward, as you would expect. However, there are some non-ohmic materials. Any material that follows Ohm's law is considered an ohmic material. And so that means that it behaves just as is. And so a resistor is an ohmic device. And so it does exactly that. Now, if we were in person still, we would be doing a lab experiment here this week or next week, in which we're using circuit elements. And one of the things you do is use a diode, okay? And one interesting thing about a diode is that as you increase the voltage, current increases like very rapidly. So in other words, if I were to look at a resistor, okay, and look at voltage and current, it's pretty much a straight line. Okay, so positive voltage, positive current, negative voltage, negative current, and it's all very much linear. This is an ohmic material. With a diode, however, then that looks entirely different. With a diode, okay, I have voltage, I have current, so what would happen is if the voltage went positive, then the current would shoot up like that. On the other hand, if the voltage went negative, the current would like drop straight down, like in other words, no matter how negative the voltage I got, I'd get either little or no current. So that pretty much makes this like a one-way valve for electricity, that if the voltage is one direction, current flows, and the voltage is the other direction, current doesn't flow. This actually has a lot to do with the symbols in the circuits. That's the resistance symbol, and it basically symbolizes that when current is trying to flow, it's resisting that because the current has to work its way through that zigzag. With a diode, then the symbol for a diode is this, meaning current flows that way, but current flowing the other way is blocked. So it's a one-way valve here. Other devices that are non-ohmic would be various types of semiconductors, in which they conduct, but they sometimes conduct well, sometimes don't conduct well. External things can influence how well they conduct. So semiconductors are non-ohmic. There's a variety of other things that are non-ohmic. Okay, so ohmic and non-ohmic materials have a lot to do with what's going on at the atomic level. And that's a little beyond the level of this class, so we're not going to really talk about that. Those that are going into electrical engineering or physics would actually talk about the band structures here, what we call the conduction band, that allows all this stuff to happen, and so how all that works. But the other thing here is that semiconductors behave differently with temperature than do resistors. And in my next lecture, I'm going to explain that you increase the temperature in a resistor and you normally increase the resistance. Semiconductors kind of work the other way. You increase temperature and you can sometimes decrease resistance, and to the point that with enough temperature, then you don't get any resistance, and basically a semiconductor fails. It's no longer a semiconductor, it's a conductor. And so computer circuits that use semiconductors will fail to operate if you try to operate them at above a certain temperature. Similarly, they also will fail to operate below a certain temperature. That if they're too cold, then you don't actually get any electrons being conducted. And so in some cases, you can get too cold as well. So they operate in this temperature realm that is ideal. If you get too hot or too cold, you end up with problems. The other non-ohmic material I want to mention is a superconductor. A superconductor would be something that conducts electricity without resistance. So basically, you start electric current flowing in it, and it flows forever without any dissipation. And so that means that it takes almost no voltage to get current flowing. And so it's a superconductor. One of the properties of a superconductor is resistance is zero. That's not the only property. Resistance zero simply means a perfect conductor. And a superconductor will have resistance zero, but there are other properties here that make it a superconductor that is a little bit different than a perfect conductor. One thing about a superconductor is that you have a maximum possible current and likewise a maximum possible external magnetic field that applies to it. And that's not true really for a perfect conductor. There really is no perfect conductor anyway. So a superconductor is a particular type of thing. For this class, we normally talk about superconductors as things that have zero resistance. But they're non-ohmic because that means that obviously with zero resistance, there's not a linear response with voltage and current.